So, hello, good afternoon. So, Celfocus is a European high-tech system integrator company that is providing professional services to bring greater business value through analytics and cognitive solutions. We have a high technology profile, a skilled team. We have been working in this telco sector for more than 20 years right now, and a global presence since we already have been working and delivering services for clients in more than 25 countries. So before going into this slide, I would like to invite you to imagine the following scenario. So envision a world where the network can recover from a fault and handle it autonomously, proactively, without human intervention, at scale and much faster. Envision a world where network can be used or can be able to anticipate faults and prevent outages. Envision a world where network can always guarantee customer service excellence without performance impact. So this is the promise of self-healing networks. And naturally, the question arises, are we there yet? Well, not quite, but we are on the way. We are continuously delivering and giving the steps towards that end game. And we know that we can go there, we know where to be, we know, and we also have a very good idea of what we need to take in place to get there, and we know that we have the right mindset and the right capabilities to support us in this journey. So our approach is based in 3 key pillars: AI and machine learning to detect issues, to identify root causes, to predict faults. Automation to speed up diagnosis and resolution by proactively and preventively taking actions towards zero-touch automation. And network as a service to allow abstraction and exposure business processes to clients and partners. So this type of approach already proved that we can achieve several key, meaningful, and impactful benefits, and they are present in many of our success stories. So I would like just to highlight some of them. So for proactive operations, where we want to have solutions that can react immediately to network signals, we already achieved 82% zero touch for first-line run operations for issue and resolution of network incidents. When we are talking about preventive or predictive networking, where we have many machine learning algorithms that help us spot failures, that can also anticipate future needs for optimizing decision making. We already proved that we can have more than 25% increase in revenue in using optimal policies for 5G network slicing, 87% success for equipment failure prediction to improve customer satisfaction and reduce costs with field services, and 80% of improvement and success in traffic and congestion prediction to enable dynamic resource allocation and preventive maintenance. So up next is Sampada, who is going to tell you one more story, one more success story that is targeting Vodafone IoT enterprise customers. And this solution aims to detect real-time anomalies for IoT connectivity service over 162 million IoT devices network in over 190 countries. So this is the solution for the next generation customer service. This is the solution that we have been building together, Celfocus and Vodafone, in order to, well, get the next milestone, so be a step closer towards this self-healing networks journey.
Thank you, Carla. Hello, everyone. My name is Sampada, and I'm from Vodafone. I lead the engineering organization in Vodafone. As Carla mentioned, AI is transforming every part of the business, and network is no stranger to that. So if you think about the journey to self-healing network, if you think about the journey to self-healing network, it starts with AI as a base for the self-healing. When we started our journey, we had many challenges that we had to deal with. We had legacy solutions that were not very operational, that also had a lot of challenges. I want to go through some of the challenges that we had in our legacy solutions. So first of all, if you look at our legacy solutions, the customers were detecting issues way before we were detecting issues. Customers were logging issues, and that was a problem because our SLAs were very rigorous, and we wanted to make sure that we were able to detect issues much before customers were able to find them. The other legacy challenge that we had was it took us about 20 to 30 minutes to validate an alarm. So if you look at the legacy solutions and how the journey has evolved for the legacy solutions, you would remember that for most of the monitoring solutions, you had to enable some thresholds, and those thresholds would then set alarms that agents would go and monitor. And that's what was happening. It took about 20 to 30 minutes to validate an alarm. And then it took about 20 to 60 minutes to assess the impact of that alarm. Now, if you look at the volume of the data that we were getting about 2,000 alerts per day. And if we were getting 2,000 alerts per day, and if it took 20 minutes to analyze every single alert, we were spending a lot of time trying to just weed out false positives in that data. And that led for us to think about what needs to be done in this area from a next generation monitoring perspective. And that's where we partnered with Celfocus. Our business drivers were really three things. One, customer satisfaction. We wanted to make sure that we increase the customer satisfaction by detecting anomalies much quicker and making sure that those anomalies were not false positives. The second thing we wanted to do was zero-touch operations. We wanted to make sure that our ops team was not spending a lot of time trying to just determine what alerts were positive versus false positives. And that's where we wanted to go for zero-touch operations. And then we wanted to scale to up to 1 billion devices. And these were three drivers towards our business case for the next generation monitoring. If you look at the architecture of the next generation monitoring, as I said earlier, we had two business drivers. One was real-time monitoring, and the other one was faster anomaly detection. Now, if you look at the real-time monitoring, and as I said earlier when the poll was taken, any AI ML journey first starts with collection of the data. Okay? If you look at the AI ML journey, really there are three steps to an AI ML journey. One is collecting the data, the other one is organizing the data, and then the third one is analyzing the data. And for us, it started with data ingestion and pre-processing. So that was the first step that we took in this journey, figuring out how do we ensure that we have the proper data ingestion mechanism and a proper pre-processing mechanism. As you can see at the very bottom, all of our data is hosted on AWS, so we're using very standard infrastructure for our solution here. Most of the solution is built using open source technologies, and we are analyzing and ingesting real-time CDRs, whether it's system logs, system metrics, or alarms. So all of these three are getting ingested, and we get about 2 billion CDRs per day. And if you look at the peak rate, we monitor about 30,000 CDRs per second at the peak rate. And it happens with sub-second latency. So looking at just the data ingestion and the amount of data that we were getting, this was a massive problem that we had to go and solve. Then the next step was ensuring that the data was captured in a way that we were able to go back and see what were the issues, even in like, let's say yesterday, day before yesterday, or an hour, 2 hours. And that's why we wanted to make sure that it was time series analytics, because time series data will help you get that understanding of what has happened over a period of time. So we wanted to make sure that we had the time series analytics in there. And then we built the portals and dashboards, of course, with the help of Celfocus, to ensure that our ops team was able to review the data, filter the data in a way that the data is meaningful for them, and they're able to analyze these records and analyze these alarms very quickly. So that's part of the real-time monitoring. Now, if you look at the anomaly detection part, the anomaly detection, as I said earlier, was manual process. And we wanted to automate that process. We wanted to make sure that we use the AI/ML capabilities to automate and detect the anomalies. And that's where we started, that's where the machine learning came into play. So we used the KNN algorithm for detecting anomalies. And all of this was integrated. And we also have an anomaly console that helps us determine what are the anomalies and reduce the false positives based on the number of anomalies that come in. The other thing that we've done, which was very smart here, was if you look at just the NGM models that we've created and the real-time track of the expected traffic trend, we analyzed. Earlier, we weren't analyzing about 100,000 time series records per every time we were analyzing the records. So this time around, we added more number of records for analyzing so that we could reduce the false positives. I don't know where this noise is coming from. So reduce the false positives such that it can help our ops team much faster. So if you look at the roadmap from a reactive to a self-healing journey, you can see that there are steps here which were manual and some were automatic. Just the data ingestion part was really automatic part here. Most of the steps that our ops was taking were just manual steps. So data incident detection was manual. Analyzing the impact was manual. Raising the ticket was a manual process. And of course, healing and escalating was a manual process as well. The next step, in this journey, the next step was really moving to proactive monitoring. So rather than having a reactive process where the data is ingested and you go and analyze the alarms, the feeds, we wanted to go to proactive monitoring. In the proactive monitoring, as you can see, most of the steps are now automated. So ingestion of the data, which was automated both earlier and now. The detection of anomaly is now automated. Analyzing the impact is also automated. And raising the incident is also automated now. So the incidents are raised automatically once an anomaly is detected and ensuring that it's not a false positive. So that was one thing that we did. And of course, our journey from proactive monitoring is really to move to self-healing. Once we've analyzed enough data and we've built the right processes in place, we will then move to using automated process for self-healing. So whether the incidents are reported or analyzed and detected using the anomaly detection algorithms, or whether the incidents are found through a manual process, we want to make sure that for both of these incidents, the analysis, the raising of the defect, as well as the healing happens in an automatic fashion. So that's where our journey has taken us from a very reactive process, which took a really long time to understand what the issues were, which took a long time for ops to also monitor and help the customers. We have now moved to proactive analysis, and then we are going to be moving to a self-healing analysis. So this is the journey that we are on, and I want to thank Celfocus for helping us on this journey.
Thank you. So now that you know more about the solution and what lies ahead, let's watch 2 videos to highlight the 2 core capabilities of the solution. So we'll start with the real-time monitoring aspect that was mentioned, addresses the faster mission. So let's imagine that we have an agent from IoT Network Operations Center that is monitoring the solution, interacting with the solution, and is monitoring IoT service usage across devices, customers, and clients. So it starts by adding monitoring to the favorites so that it can have a quicker access later on, and then it goes through the monitoring. So typically, he uses this to scroll down quickly over the visualizations and understand at a very high level what is happening with the services. How are they performing? Here you can see that data is available at a very granular level, and the users can interact with this through multiple dynamic filters to analyze and better understand what is going on. Here the user is applying a customized time range filter, and look how fast the visualizations are updated. Now he proceeds with his analysis. There is something that catches his attention. There is an unusual peak over there. So he wants to flag it. He creates an annotation. He can check it later on, or for instance, his team can check it later on. And also notice that this type of user inputs can also be used later on for model optimization. So now we can see that, in fact, in this visualization, we are looking at data from more than 62 million subscribers. And all of these can be analyzed. We can also apply additional filters. Here, the agent is selecting a specific client and a specific country to analyze further the solution. Again, look how responsive and interactive it is to slice and dice network traffic data in order to better do the analysis and the troubleshooting. And also, the significant leap in quality and in speed that this represents for this type of solution. So this solution is able to scale. This was also a request up to 1 billion devices very easily and guarantee the same levels of performance. So now let's move further with the anomaly detection part, which addresses the second mission, so the better mission. And here, the agent goes directly to the anomaly console, where you can see all the generated anomalies from the solution that are presented by the different status. So it wants to analyze the closed anomalies, in particular the ones with SMS protocol. So there are 3 of them. He is going to start with the first one, and is going to check more information that is available for that type of anomaly. So it goes straight to the charts because it's easily to spot the issue, and it can easily find where is the drop in the pattern. So now it can flag this anomaly. It can automatically also create the incident so that all the management can happen before the customer complaint. All of this is happening very fast at the visualization layer, as intended. But there are a lot of things, as it was also mentioned before, that are happening under the hood, and that I would like also to highlight. So in this particular case, it was an anomaly coming from an automotive client. In particular, this specific anomaly represented that the clients were not able to connect or to send SMSs anymore at that time. At that time. But in the IoT world, there are many other industries represented. There are energy companies, engineering companies, and many others. And all of the IoT devices from all these different industries exhibit completely different patterns of behavior, which makes this anomaly detection a much bigger challenge. So the solution has statistical analysis over time series to identify the patterns, and it also has ensemble learning with multiple machine learning algorithms that compete against each other to find which one is the best fit for each anomaly scenario. And the solution is also able to employ clustering techniques to group anomalies that are related with each other, so that somehow relate to the same issue, so that only the group is presented for the operator. Also, and to end, it has also the capability to do service impact analysis, to understand to what degree the service is impacted, and also based on that, recommend priorities for the anomalies. So in the end, this type of solution is providing the relevant insights and the required context very fast, very accurately to the IoT operations team that can then minimize, lower, decrease the minimum time to detect, to resolve, and also decrease the number of customer complaints. Thank you.